In section 5.9, we are going to look at the different properties between squares and rectangles. So starting off with a square, we know that the four sides of our square are all congruent. So that is a property of only a square because a rectangle has two sides that are congruent. So down here, we're going to write the properties of our square. Our first one is that four sides are congruent. For our rectangle, we have two pairs of sides congruent. Okay, when we look at the angles of our two shapes, we know that both these shapes have 90 degrees in all four corners. So that is a property of both a rectangle and a square. Okay, then we also know that our diagonals in both our shapes are congruent and they bisect each other. So our line MT and AH are congruent and bisect each other. So this and this are going to be the same, and these two are going to be the same. So they are congruent and bisect each other, and same with over here. These are congruent and bisect each other. Okay. The difference in the diagonals in a square versus a rectangle is for a square, our diagonals are perpendicular. So all of our angles in the middle are 90 degrees. So for a square, diagonals are perpendicular. Our diagonals in our square also bisect the angles in the corners. So since these are each 90 degrees, that means all of these angles are all 45 degrees. So that is just for a square. The diagonals bisect angles at corners. And then for our rectangle, all alternate interior angles formed by our diagonals are congruent. So this is similar to our parallelogram, where we have this angle right here is going to be congruent to this one. Same with this angle and this angle. Alternate interior. And then this angle will be congruent to this angle. And same with this side. So our rectangle are alternate interior angles. Okay, there we go. Our alternate interior angles formed by our diagonals will be congruent. If you look at the inside of that that rectangle, you'll notice that there are isosceles triangles created. So right here we have one of them where we have an isosceles triangle because our two angles and our two sides are congruent. So there are 4 isosceles triangles created inside. Okay, so we got isosceles triangles formed inside of our rectangle. So now we have a few examples. The first one says find the missing measures in rectangle ABCD, and we are given that this side is 12, and our other given information on this rectangle is that this one is 16. And our diagonals, let's draw those in. Our whole diagonal here is 20. This is 0.0. And we need to find the rest of our missing information. So BC is our other side, that's going to be 12. AB is our other side, that will be 16. And then we need to find DB. Well, we know in a rectangle, our diagonals are congruent, so if AC is 20, DB is 20. And we also know that those are bisected, so if the AC is 20, then those two pieces, AO and OC, are each going to be 10. And then same thing with DB. If that whole thing's 20, each one of those pieces is going to be 10. Okay, so now in our next rectangle, we are given some information. Let's draw our diagonals in here. We are going to label this as 5, 4, and 3. This is 32 degrees, 2, 1, and 6. Okay, so if that's our given information, we want to find the missing angles. First of all, we know that this angle here is going to be 90 degrees. So if this is 32, 90 minus 32 gives us 58. So that makes angle 4 58 degrees. Now we know that angle 4 and angle 5 are going to be the same because this is one of our isosceles triangles. So angle 5 is also going to be 58. And then we also know that 5 and 6 here are alternate interior angles, so 6 will also be 58. And then if we know that 6 is 58, this whole thing again will be 90. 90 minus 58 gives us 32. So angle 1 is 32. Now to find angle 3 and angle 2, we know that these two angles right here are both 32 degrees. If we have 180 degrees inside of our triangle, 32 plus 32 is 64. So let's write that over here. If we take 180 minus 64, that leaves us with 116 degrees for angle 2. And then to find angle 3, we know that 2 and 3 are going to add up to 180. So if we take 180 minus 116, that's going to leave us with 64 degrees for angle 3. Our last example here is a square. And so this is our given information for example number 3. First thing we want to find is AB. Well, we know that AD is 6, and if it's a square, then all 4 sides are going to be equal. So all 3 of these will be 6. So AB is 6, AC is, just AB is 6. Okay, so then we want to find AC. Well, if we know that DB is 10, we know that AC is also going to be 10. Our two diagonals are equal in a square. To find DM, we know that DM and BM are congruent. So if the whole thing's 10, then each piece is going to be half of 10, which is 5. Same thing for MC. That whole thing's 10, each one of these pieces will be 5. For our square, our diagonals bisect our corner angles, and since the whole thing is 90, angle 1 is going to be 45. And so look back at our square at the top of our last page, you'll see that all those angles are 45. Same with angle 2. And then for angle 3, on our square at the top of our last page, you'll see that all those angles in the middle are equal to 90 degrees. And then same with angle 4 as 1 and 2, that one will also be 45. And then our last angle, it's asking for DAB, which we can trace right here, DAB, which is this whole thing right here. And we know the corner of a square is 90 degrees.